I want to firstly go over indices rules and surd rules, right? Hopefully you all remember these things. So if I give you these rules, when you multiply the same base, what you do? Whenever you have the same base, what you divide in, what you do? If you have same base, well, sorry, not same base, but you have a to the m multiplied by a to the n. This will be what? That's multiply, right? One thing I want to point out here, right? I think we did it somewhere, somebody did it. If you have a to the power 3 on 2, right? Or any function to the power 3 on 2. This is the same as writing a to the half all cubed. Correct? Or a cubed all to the half. That's okay? So there are two ways that you could write this. You could write the square root of a and a cube in it, or you could write the cube root of a and a square root in it. All right? Anyone could do it. Anything to the power 0 is 1. So anything to the power 0 will always give you 1. If you have a to the power of m over n, right? That's kind of what we did here, right? It will be a to the 1 on n all by m. Or we could write it like this, the nth root of a to the power of m. So this rule, right, is the same as this rule technically. See enough? Right, the only thing that you have to identify here is what the n means. 1 on n means. Right? 1 on n means that. All right, so these are some of the indices rules that we need to remember. And we could jump into the surd rules one time. Right? Same thing here. If I give you the square root of a and you multiply by the square root of a, same base. Square root means to the power of a half. So a half and a half is simply 1, right? So root a by root a is a. Okay? What about if you had root a multiplied by root b? That will be root ab, right? You can do the whole thing and multiply the a by the b. Right? That's 1, 2. Next thing we need to remember, suppose I gave you root a, or suppose I gave you a over root a. What you'll get? No, but let's simplify even easier. And a is what? A is what? A is root a by root a all over root a. So the answer is root a, right? That's okay. No rationalizing as you're coming to that. What is root a minus root b by root a plus root b? Work it out. Work it out far. Right, so what you'll get? Root a by root a is root b by root b as b. Or you can just use difference of two squares, right? And work it out. Right, so this is used for if you have something like this, right? A plus root b over c minus root b. How do you simplify rational fractions? So to simplify it, what you want to do is you want to rationalize it, which means we're going to find a way to turn this third part into something rational. Okay, so you multiply by conjugate of this. So whatever sign you have in the middle here, change it. Negative becomes plus. All right. So during this process of going from this fraction, right, we do something called rationalization. What I will do is when you multiply the denominators by the conjugate of itself, right, this will now become a real number like this. All right. So what you're really doing in the denominator is you're making it real, right? Look at the denominator. The denominator c minus root d, c plus root d is what? It will be c by c, which is minus root d by root d, which is d. That's okay? So it's always this squared minus this squared. That's okay? And this is something real. Okay? Have no more surds again. right? And then the numerator, well, we had to work out that, right? Right, so we'll try an example then. All right, so we want to simplify this here. How you will simplify this fraction? Multiply by the conjugate of the denominator. So you're multiplying the numerator by the conjugate and the denominator by the conjugate. Right? So you're multiplying the numerator and denominator by the conjugate of the denominator. Move it up back. Let's see what we got. Right? Let's see what you got. Right? So you're multiplying root 3 by root 3. That's 3. Root 3 by root 2. That's positive root 6. Root 2 by root 3. That's positive root 6 again. Root 2 by root 2. That's 2. All over. Right? No need to multiply it out. There's a conjugate. So it's root 3 squared, which is 3. Root 2 squared, which is 2. Right? So that's over 1, right? 3 plus 2 is 5. Plus root 6. That's 2 root 6. 3 minus 2 is 1. Take your time when you're multiplying this out. Right, so multiply by 2 root 5, right? Conjugate of this, right? What I got you? Yes. Right, how this looks. Right, let me just remind you something. Remind you of something. If you're multiplying 3 root 5 by 2 root 5, 3 by 2 is 6. Root 5 by root 5 is 5. So the answer is 30. All right? So when you're multiplying something like this, don't multiply 3 by this and 3 by this. Huh? This is 3 by 2, which is 6. Root 5 by root 5, which is 5. Yeah. All right, so 3 by 3, that's 6. Root 5 by root 5, that's 5. 3 by 4, that's 12. Root 5 by root 3 is root 15. 2 by 2 is 4. Root 3 by root 5 is root 15. 2 by 2 is 2 by 4 is 8. Root 3 by root 3 is 3. And the denominator is just 2 root 5 squared. 2 root 5 squared minus 4 root 3 squared. The numerator is what? 30 plus 24. That's 54. 12 plus 4, that's 16. Okay? All over. 2 root 5 squared. 2 squared is 4. 4 by 5 is 2 squared is 4 squared is 16. 16 by 3 is
28.
right? So when you minus it off, it will be 54 over 20 minus this. Minus 16 over 28 root 20. Right? So I just divide both of them by minus 28. Huh? What's that? Yeah, I can reduce it. How much is that? Here is minus 27 over 14. And here is 8. All right, 9. Okay, so that's just it. Let's check out the next one. One a little bit longer. It's a past paper, right? This is 2008. And that was number 1B. I cannot change it. So I want to add this to this. right? I'm multiplying, I'm gonna find the LCM and work it out, right? So if I find the LCM, I'll get root 6 minus root 2, root 6 plus root 2. Right? When I multiply this by this will cancel, and I'll get root 6 plus root 2 by, and here I'll get root 6 minus root 2 by. Underneath here, you will get 6 minus 2. Here you will get root 6 by root 6, that's 6. Root 6 by root 2, that's root 12. What's root 2 by root 6, Shirish? What's root 2 by root 2? Right? Root 6 by root 6 is 6. Root 6 by root 2 minus root, minus root 2 by root 6 minus root 12 minus by a minus is a plus. Root 2 by root 2 is, this will cancel. 6 and 6 is 12 plus 4 is 16. Right, they want in this year, this is 2005. Number 3, they want you to show quickly that root 11 plus root 7 is equal to 4 over. You have to show that. How are you doing that? So you can work with the right hand side, simplify, and it should become that. Yeah? Go ahead. So what's the multiply by here? Multiply by the conjugate of the denominator over itself, right? So that's root 11 plus root 7 all over root 11 plus root 7. When you multiply this denominator here, you will get 4, or sorry, the numerator will give you 4 by this. And the denominator is root 11 by 11, root 7 by root 7. All right, and that will give you, this is 4, so this will cancel with this and give you, right, and that is your left hand side. Yeah. All right, so that's technically what you're going to see in surds, but you will see surds more, right? You're going to have to apply more surds like when you're doing trig questions and simplifying it out. Right, you might just see one looking exactly like that. Right, let's try some indices. 2004 had one. Right, in 2004, the first part, which was easy, they wanted to show that 4 over 2 to the x is equal to 2 to the 2 minus x. Right, and then they wanted to solve something after. Same question. They want you to solve 2 to the x plus 2 to the minus x is equal to 5. Anybody remember what they call these? What they call these here? In this guys, quadratics. So somehow this has to be a quadratic, right? Right? So you take the left hand side here, Shavish, and 4 is what? 4 is 2 squared, right? This symbol here means divide 2 to the x. Same base, division sign. So we minus. So you'll get 2 to the 2 minus x. That's all they want. Right? This one here is a little problem though. This one here, we have to find a way to convert it to a quadratic. Right? What does the minus sign mean again? We just proved it there, right? So this is 2 to the x plus 2 squared over 2 to the x. We're going to cross the 5. Right? This is confusion. So what to do? Okay, yeah, you can multiply, or we can, this is looking kind of confusing, so we can let y. Let y equal to 2 to the power of x. Right? So we're going to get y plus 4 all over y minus 5 is 0. What's the next step? Multiply by y. So you'll get y squared. plus, sorry, minus 5y plus 4. And we have our disguised quadratic. Or you just know when that disguised quadratic, you see in the indices and you end up with 1, 2, 3 terms. Once you see in those 3 terms, somehow or the other is a quadratic. You have to figure out what to make the substitution for. So what you got here? Y is 4 and y is 1. Right? Y is really what? Y is really 2 to the power of x, right? So 2 to the power of x is 4. So we can solve this here. Right? 4 is really 2 squared x's. Right? And then you do the next one. 2 to the x is 1. 1 means what? 1 means 2 to the power of 0. Excellent. So your two answers are 0 and 2. That's your right? And you can just plug it in and just make sure. Right? There's the next 2008. 2008 has two years. Without a calculator, evaluate this. 27 to the power of 10 plus 9 to the power of 10 all over 27 to the 4 plus 9 to the 11. Right? That's a 10, that's a 10, that's 4 and 11. All right? Without a calculator, see if you can work this out. Right? The hint is to make sure you can factorize properly. Right? So you can convert them all to the base 3. Right? So that would be 27 is 3 cubed by 10. So that'll make it 30. 3 squared by 10. 3 squared by 10, so that'll make it 20. 3 cubed by, so 3 by 4, that'll make it 12. 3 squared here, 2 by 11 is 22. Right? What can we factorize out here? What you'll factorize out on top? Azaria said 3 to the 20 on top. And you will get 3 to the 10 here, plus 1. Right? This by this, giving you this. This by this, giving you this. And underneath, factor out 3 to the what? 12. 3 to the 12 from this will give you 3 to the 1. 3 to the 12 from this will give you 3 to the 10. And we're good to go. What will happen here? These two are the same, right? Wait, someone wrong here. It should be 1. Yeah. Right? These two are the same, so this will cancel. And you will end up with the square root of 3 to the 20 divided by 3 to the 12. Same base, division. So we're going on minus. So that's 20 minus 12. So that's the square root of 3 to the power of 8. And we know that square root is to the power of a half. 8 by a half is 4. So the answer is 8. All right. So if you see a question like this, and it's not something that are general, you have to be able to do generally as well, right? Generally, to solve something like this, you have to find a way to factorize. If you have to simplify something like this, all you can do is to find a way and factorize something on top and something on the bottom. That would allow you to cancel and something. Yeah. Right, 2015, number 2B. Right, by just watching it, it looks like a what? This guy, right? Right, so Brianna said to let y equal to 9 to the, it's not working out. So if y is 9 to the x, what is y squared? 9 to the, which is the same as 81 to the x, right? So I can take off 9 to the x and I can write y, and I can take off 81 to the x and write y squared. Right? But it's fractions, right? So you don't want to work with fractions. So you multiply everything by y squared. So you'll get 3y squared minus 4y minus 4 is 0. Y is 2 and y is minus 2. Y is minus 2. But remember, y is really what? Y is really 9 to the x. Right. I want to point out something here. Could 9 to the x ever give you a negative value? Is there any x value that could ever give it us? No. So therefore, 9 to the x equals to minus 2/3 has no solution. That's okay? And anybody remember from mathematics how to solve this? Right? Technically, I didn't show you that yet, but you should have known that from before. But you have to take logs here to solve questions like this. So you take log on both sides. So when you take logs, you'll get x is equal to log 2 over log 9. Right? But I'm not jumping into logs today. I want to focus on the exponential function. So here is something that I want to finish up the class with, right? We would like to try to get a sketch of that graph. Y is equal to a to the n. If you want, we could use y is equal to 2 to the x to 1. It don't matter, right? They always have the same shape. Right. First thing first, right? If we had to sketch something like this, what's the first point we could use? X is what? X is 0. When x is 0, right? 2 to the 0 is 1, right? So when x is 0, y is 1. So it's passing through there. Right. Question. Is there any way I can make y negative? Is there any x value I can put here to make y negative? No. If I put -4 or -20 or -1,000,000, what you will get? You'll just get a fraction, right? Think about it. 2 to the -10. And that's 1 over 2 to the power of 10, which is a fraction. So is there any way this could be negative? There's no way for this graph to be down here. Right? So that graph doesn't exist in the negative part, and we saw that with that solution. There's no value for x that would allow us to give us a negative value. Are okay with that? So whenever these values become negative, they're getting fractions, right? So they're getting small values. Could this ever be 0? Yes, really, when it's an infinity, right? But really and truly, no, it won't come. So all that will happen to this function as we use x negative values for x, it will come real close here. These fractions will get smaller and smaller, right? But it doesn't come to 0 unless it's infinite, right? That's the ideal case. Okay with that? So whenever x is less than 0, it looks like this. But when x is more than 0, how will it look? It'll keep getting bigger and bigger and bigger and bigger, right? So it will keep growing. So what you have there? That's it. That's the general graph for y is equal to a to the x. If a is 1, it generally looks like this. If a is 2, it looks like this. If a is 3, it looks like this. Okay? And there's a special function. If a is equal to e to the power 1, that's the exponential function. Right? If a is equal to e to the power of 1, a, or just e, right? We have the famous exponential function. Right? We have the exponential function y is equal to e to the x. We'll see if we figure this out. What do you think y to the x will look like? Same thing. Yeah. Same thing, right? So y equal to e to the x will look like that. And what you will recognize is the same way we solving this. Watch. Same way we solving this. The same way we solve functions with E. Same rules apply. Right? So like something like this, right? So for example, if I give you e to the x multiplied by e to the x, same base, add the powers. Same rules apply. Right? Same rules apply. If I give you e to the 2x divided by e to the 3x, same base, so you subtract powers. So everything you do with indices, everything, same thing you can do with the exponential function. Right? This is a special function because it could be applied to plenty of real life things, which I'll show you. When you all start doing modeling questions, this is one of the functions that you could use to model something with. All right. Just do my quick favor and just squeeze in here the exponential function, right? Right. What you said. This line is on a asymptote, right? So this curve comes close there. Close there. Okay. So do like touch, right? So this is the function of that. How you remember? Always remember that it cuts the y-axis at 1.